Season 3, Episode 9, asking about the velocity of a body moving according to this formula. Part A requests the distance travelled in the first 4 seconds. Now, we have to be careful with that term. It asks for distance. Now, distance, it doesn't matter whether that's travelling towards you or away from you. It wants the total distance. To cut a long story short, that means we're going to have to be very careful about the intercepts here. So the points where velocity is equal to 0. So first up, I'm going to basically check our x-intercepts, which is this, in this situation, check for when v equals 0. So if I go 0 equals t cubed take 3t squared, you might go, oh no, we've never actually taught you how to solve something like that. It's got a power of 3 in it. But this isn't too bad because we can factorise out t squared. If I factorise out t squared times what would give me t cubed, it'll be t, and t squared times what gives me negative 3t squared, you get that expression, which essentially is t times t take away 3. So the intercepts are essentially at either t equals 0, because if t is 0, that will make that whole expression true. 0 times anything is going to be 0. Or t take away 3 equals 0, meaning t equals 3. That's a bit of an issue because the range that we were meant to look over is the first 4 seconds. The first 4 seconds we envision as being when t is from 0 to 3. So to do this properly, to find the total distance travelled, we're actually going to have to integrate over 2 ranges. We're going to have to integrate between 0 and 3 seconds and between 3 and 4 seconds, because there's a point there where the velocity hits 0 and starts going in the other direction. We need to be careful about that, or potentially going in the other direction. So what I'm saying is that the distance travelled, this is going to be a big bit of work now. The distance travelled is going to be equal to the distance travelled between 0 and 3 seconds plus dt, I need to make that dt, plus the distance travelled between 3 and 4 seconds. Sometimes to do this properly, you'll notice that we'll put in absolute value signs, which says, well, distance has to be a positive number. So that forces whatever we get out of those individual bits to be positive. So let's do that. So integration, power goes up by 1, divided by new power. Here, power goes up by 1. I'm going to make this a bit simpler here. It's just going to end up being t3 here. Because if I put the power up by 1 and then divide by 3, I'm going to lose the 3 at the front. So it's going to be whatever I get out of that, plus the integration is going to be the same. t4 over 4, take away t3, between 3 and 4. Again, I could put the absolute value there to make sure that it's only the positive value of that I care about. So on this side, I've got to put in 3 and then take away what I'd get if I put in 0. So it's going to be 3 to the power of 4 over 4, take away 3 to the power of 3. Take away what happens if I put 0 in that. You probably can see if I put 0 in that, the whole thing's going to end up being 0. And then I need to add on this side what happens if I put 4 in there. 4 to the power of 4 over 4, take 4, 3. Take away what I get if I put 3 in there. Right, again, make sure that I want the positive variant of whatever comes out of that side, plus the positive of whatever comes out of that side. Start putting it in your calculator, if you want. So on this side, 3 to the power of 4, take away 27. Whoops. 3 to the power of 4 divided by 4. Right, it's giving us negative 27 on 4. But of course that has to be a positive value, distance we're only regarding as being positive. And adding this stuff, which is going to be huge. That's actually going to be 0 there. 4 to the power of 4 divided by 4 would be 4 to the power of 3, take away 4 to the power of 3, so I'm going to ignore that. So that evaluates to 0, leaving me with just negative whatever we get out of there. We actually already know what we're going to get out of that. So negative of that will just be 27 on 4. So you're going to get 27 over 4 plus 27 over 4. Simplify that down. So 27 over 4 times 2. I could have done that without a calculator. Or 13.5. So we found that the total distance travelled is 13.5 metres. Now I probably should have mentioned right at the start there that if we ever want distance travelled, how is distance related to velocity? Integrate it. So if I integrate velocity, I get displacement. Right? Difference between displacement and distance is distance doesn't really care whether it's positive or negative, which was pretty important in answering this question. I think that's about it. Cheers.